Welcome back. So before we continue, there are two more things I want to mention. The first one is the reason that Stata is a very popular software is because Stata has a really robust help function. So if you get confused about any kind of command, for example, I'm confused about the CD, the changing directory. Usually students, when they're starting out, CD is a confusing command. So how do I get more information about the CD command? All you need to type in the command window is type help, CD, whatever command you want, and type enter. And Stata will have a help file popped up for you, and it's going to tell you, give you more information about that command. Okay, and it's also going to give you a little bit more information about how to use that command. All right, so that's the first thing I want to mention. And the second thing I want to mention is that if let's talk about this data set. So if you look at this data set, you can see that here I have Afghanistan 1990 all the way to 2020, their GDP, their population, their employment share, a lot of information, right? And then I have Albania from the same time period, 1990 all the way to 2020. Algeria, same time period, 1990 all the way to 2020. So 30 years of all the countries that we have in this world. Okay, so here you can see that we're following multiple units of observation over multiple periods of time. And we're following the same units because I'm following the same country, Afghanistan, for 30 years. I'm following Albania for 30 years. I'm following Algeria for 30 years, and so on and so forth. I'm now changing my observation. So as a result, this data set is a panel or longitudinal data set. Okay. So these are the things I want to mention. And after that, we can continue. So the next thing we're going to learn is how to import dataset. So one thing that you probably have already noticed that when it comes to Stata, Stata works in the dataset with a format .dta. So .dta is a Stata-specific format, but it doesn't mean that Stata cannot read other formats. For example, Excel and the CSV formats, which we're going to talk about a little bit later. So how does Stata read these other formats? Stata uses the import function. So how do we import different data sets and save them into Stata-specific formats so that we can continue work within Stata? Well, it's very simple. The command is just import. And you can see that Stata has already anticipated what you wanted to type. So what you need to do is I'm just going to tell Stata I'm going to be importing Excel files. Okay. So how am I going to import Excel files? Well, remember, we are still working under this directory, so we don't really have to tell Stata the whole path of this file. All I need to do is I'm going to copy the whole full name of this file and paste it here. I want to import Excel census 1990 to 2000.xls, and then on top of that, I'm going to type first row. Let me show you why we're doing that. So first of all, let's just double click this Excel file to see what we're looking at. Remember, this file's name is called Census 1990 to 2000. That means this is the American Census. This is a subsample of the American Census. The first sheet you see here is the 1990 American Census, and the second sheet you see here is the 2000 American Census. These are individual level data, and then we have each individual's persons, for example, the city that they live in, their gender, their birth year, their race, whether they go to school, whether they're American, and all that, whether they're employed, all of those information over here. Okay, so I have each and every individual person's information over here. And because this is the individual level data, we can't really show people's names. And the way to uniquely identify people is by the serial number and the how and the individual number that we're going to see a little bit later. Okay, so here you can see that the data set has this kind of format, same kind of format, right? But unlike Stata, the names of the variables are not at the top, it's on the first row. And that is why if you look at the code here, you're basically telling Stata, I want to import this data set. At the same time, I want to tell you the first row is actually here. You can see that it's not observations, it's actually the variable names. And that is what happens when you import this data set. So if I just click do here, Stata will import the data set. Well, actually, before that happened, you can see that Stata actually threw out a error message for me. It says, no, data in memory will be lost. Again, this is Stata trying to stop you from making a mistake. Remember, we have a one single data set already open. So when we try to open another data set, Stata is going to say, no, 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 you're probably going to lose your information from the previous data set, so I'm going to stop you. So again, this is why I said that clear is the single most important command that you're going to use, because right now we know that I want to clear, I want to get rid of the previous data set. So I'm going to import clear before this import line of code so we tell Stata, okay, you can get rid of the previous data set. I don't need to use it anymore. Okay. So if I click do again, you're going to see that Stata this time didn't yell at me, and Stata has imported the Excel file. And if you look at the data set, and you're going to see that the first row becomes the column names, becomes the variable names. It didn't take over the first line. Okay, so this is how we import how we import Excel file. But wait a minute. If you look at the years, you're going to see that the years of this data set only goes to 1990. But wait a minute. If you look at the Excel file, there are two sheets. So that means Stata only imported the first sheet because the second sheet is the 2000 census. So remember, we said that Stata only imports one data set at one time. So this is basically Stata saying, I'm going to default to only import the first sheet. Okay? So it imported everything successfully, but it didn't import the second sheet. But before we do that, let's actually make sure that we save this data set into a Stata data set so Stata doesn't have to keep on doing the importing, and we just save it as a Stata, and then we can just work within Stata. So again, the way to do so is to save it. I'm just going to call it census 1990.dta. And I'm going to tell Stata to replace if there's already a data set called census 1990.dta. So if I click do val again, you can see that Stata has saved the census 1990.dta. Stata actually just said that, okay, I didn't find this data set in your folder, so I'm not going to worry about replacing it. I'm just going to create this data set for you. And if you go to your folder, you can see that the census 1990.dta data file is created automatically for you using your code. Okay. Next, the question becomes, okay, how do I import the second sheet? Well, very simple. I'm just going to copy and paste this line of code. I'm going to add one more option. And the option is sheet bracket. Actually, there's no space between sheets and brackets. So sheet bracket title 2000. So this way, I'm telling Stata to import the Excel file, the same file, but I'm going to tell Stata to identify the sheet with the name, the spreadsheet with the name 2000. And then the first row, just like before, is still the variable name. Okay. So I'm going to click do again. And then you can see that Stata still said no, data in memory will be lost. So what do we forget again? Well, we forgot to clear again, right? Because again, Stata has a data already open. Stata doesn't want you to accidentally close a data set. So Stata said, no, you need to manually clear everything again. Okay. So again, if we click do again, Stata runs everything. And if we look at the data set, you can see that now the year is 2000. That means it has successfully imported the second sheet of that data spreadsheet, Excel spreadsheet. And then I'm going to save it as census because it's the year 2000. I'm going to save it as census 2000.dta, replace. And if I click the do val, everything will work. And let's double check. The result says everything will work. And you can also see that the census 2000.dta is automatically created for you. Okay. So here, let's take a pause and just double check the topic one log file, SMCL file again. Remember, the log file should record everything that we have done. So if you just go to the log file, you can just see that log file has become a lot longer, and it's including all the importing files and saving all the files and things like that. So the log file is recording a lot of things. Okay. Now, Next, I have the 1990 census, I have the 2000 census, and if we look at our folder, where's our folder? If we look at our folder, you can just see that there's another 2010 census, but you can see that this 2010 census has the file type of CSV, not XLS, which means it's not Excel file. In fact, if you actually double click and open it in Excel, it doesn't. It's just mumbo jumbo. And the reason is this is a different file format, and instead of arranging all the variables by columns, it's separating all the variables by commas. So CSV actually stands for comma separated variables. So all the variables are not arranged by columns, but they're separated by commas. This is just a more primitive version of the data organizing kind of format. But we still want to import this. So how do we import this CSV file? Well, we cannot do import Excel anymore, right? Because it's not an Excel file. But before we do that, let's make sure we're clear, right? And then we type Excel. This time, we're going to choose delimited, okay? So that just means that it's separated by some other thing other than Excel, okay? So import delimited, and then we're going to type the file name, which is census 2010.csv, right? So I can just copy the name, census 2010.csv, and then remember, with this data set, just like Excel, the first column, you can see the first column here is still variable names, right? So we still need to tell Stata the first column, sorry, not the first column, the first row is still variable names. But because this is now Excel, it doesn't technically have a row. So we actually need to use a different option, which is var names 1. So basically, this is just saying that you see the first line here, that's the variable names. So it functions just the same as the first row. It's just a different kind of syntax because we're dealing with a different file format. Okay, so if we click do file again, you can see that the result says, okay, I have imported the 2010 file. And you can see that the first line of code, the first line is still the variable names, and then we have the 2010 census here. Okay. And of course, now that we have imported everything, let's save it. And non-surprisingly, I'm going to call it census 2010.dta, and we're going to replace again. And then I'm going to click do, and everything should run. And if you check your folder, you're going to see that the census 2010.dta is created for you. Okay, so again, let's pay attention to this 2010 dataset. This 2010 dataset is the cross sections, right? Because I have the individuals in 2010, all the individual characteristics. So we have multiple units of observation over one period of time, right? That is a cross sections. Maybe what I want to do is that I want to combine the 1990 census, the 2000 census, and 2010 census all together. I want to pull all the cross sections, the data set together and create a pooled cross section. Okay. So how we do that? Visually, what we're trying to do is basically doing this, right? I want to combine the 1990 cross-section and append the 2000 cross-section underneath the 1990 cross-section, and then append the 2010 cross-section underneath the 2000 section. Why? Is because if you look at the 2010 cross-section, you'll have the variable year, sample, serial, CB serial, HH weight, right? So these are the variable names. And if we just double click, for example, the 2010 census is year, sample, serial, CB serial, HH weight. So all of these variables are the same. The observations are different just because we're looking at different people in different year. So we're basically, just like the visual representation here, we're vertically stacking different years cross sections together vertically. And that is why we call it append. Okay. So how are we going to append the three cross sections data together using code? Well, very easy. Before we do anything, clear. And then we're going to start with the data set that's going to be at the top, which is the census 1999, 1990.dta. And after that, the command is append using. So I'm going to append the census1990.dta using another census data called census2000.dta. Okay, so if I click this, do Stata will append the 2000 observations underneath the 1990s observation. So you can see that the first portion is the 2000 observations, and then our sample size, I think, is 5,000. So if we go to observation 5,000, you can see that this is still 1990, and then by 5001, it changes to 2000. So we basically attached the 2000 cross sections into the 1990s cross section. So now I have appended the 2000s cross section into the 1990 cross section. I don't want to stop here, right? I want to also keep on appending using the census 2010.dta because I want to keep adding to it, right? So as a result, you can see that if I click do, the new data set is going to have 1990s observation at the top, 2000s observation in the middle, and then 2010s observation at the bottom. Exactly what we have done here. 1990 at the top, 2000 at the middle, and 2010 at the bottom. Okay? So after this, because we have successfully appended all the data sets together, let's make sure we save. So we're going to save it as census 1990 to 2010.dta. And if I click do, the data set will be created over here, the census 1990 to 2010.dta. Okay, so this data set is created for you. But here's the thing. If we want to look at the data set, you can see that for each individual person, right? Because it's a cross section, we're not following the same people. So the 5,000 people in 1990 are probably gonna be not gonna be the same people as the 2,000, 5,000 people. But all of those people, we have their information, like where they live, their birthplace, their education, whether they participate in the labor force, which industry they're in, which occupation category they're in, their total income, their total wage, so on and so forth. But one of the more important, crucial information that we have forgotten to include here is actually people's wage. Because a lot of times people's education, people's wage, people's income, a lot of information depends on their wage, people's health depends on their age, right? So right now I'm missing all of these people's age information. How do I do that? So I want to actually add these people's age into our data set. So how are we going to do that? Well, first of all, you can see that from our data set. Luckily, we have another data set, which is the census 1990 to 2010 and their age information. It's the exact same people and their age information. So if we just double click here, you can look at this data set and you can see that we have 1990, 2000, and 2010, and we have their age information. We know their age. And two more things that you want to pay attention here is that I also have two more variables here, serial and per num. Okay, so in this age data set, I have a serial number and a per num number. So the way that the American Census is the data is collected is by households. So these serial numbers are unique serial numbers to the household, and per num is the person's number within that household. Usually, one means the head of household, two means the spouse of the head of household, three, it could mean the parents of the head of household or the children of the head of household. And basically, the higher number that you see, the more number of people there are in the head of household. You can just see that there's actually somebody who have 8 people in their household, right? So basically, with the combination of the year and the household serial number and the person number, we can uniquely identify a specific person. So again, let's just look at well, let's not look at this. Let's look at our 1990 to 2010 census. You can see that there's also the serial number here, and the person number is somewhere. You can see the person number is here. So basically, we can use the year and the serial number and the person number to uniquely identify a specific person, because within a specific year and within a specific household, there's only one head of household, or there's only one spouse of the head of household, right? So that way we can add this new variable to the end of the data set. Remember, when we're adding a new variable, we're not adding rows, we're adding a column, right? So we have year, we have sample, we have serial, we have, for example, sex, right? We have the income and wage. Basically, what I want to do is that I want to add a new column, which is age here. And I want to make sure that this person here with a year, the serial number, and the person number matches the person that we see here with a year, serial number, and person number. Remember, you can see here, there are 15,000 observations. You can imagine if you're going to manually do this in Excel, it's going to take you a long time. And this is again why when you deal with big data sets like economists do, we don't use Excel, because instead of using one line of code, Stata is using Excel is going to take you probably a day or two, and then you're probably going to make mistakes along the way, right? So basically, the visual way of telling you what we're trying to do here is that you can see that what we're doing here is that I have a first data set, which is the data set without the age variable, and I have the second data set, which is the data set with the variable. You can see that ID1 and ID1, the first person matches, the second person matches, so I have 5 people here, 5 exact same people here. And if I want to add this data set to the end of this data set on the right, instead of using append, I'm using merge. I'm basically merging two data sets horizontally to add the data set 2 to the right of the data set 1. Okay, so that is what we're going to do. So here you can see that we already have the data set. So, but before we do that, let's just clear and make sure we start in a good footing. So we're going to use the census 1990 to 2010.dta dataset. Okay, so this way I'm starting with the dataset that I want to look at. So it says it already exists because, again, I forgot to type replace. Okay, so after we type replace, everything runs, and I have the census 1990 to 2010.dta in here. And the next thing we're going to do is to merge this new age dataset into the original dataset. Again, if you get confused about the merge command, there is this merge command help file for you. So when it comes to merge, there are various ways of merging the dataset. You can either do a one-to-one merge. That means the specific observation from the original dataset and the new dataset that you're trying to use to merge into the original dataset, there's a one-to-one match, meaning that if there's a person in the original dataset, there's the same person in the new dataset. There could also be a many-to-one merge. If we have a many-to-one merge, you can imagine that maybe the original data set is, let's say, a city level data set. Okay, so I have sorry, it's an individual level data set. So I have, let's say, 100 people in Swanee, right? And this one data set, the using data set, is, for example, a city level data set or a university level data set. So maybe the university has some kind of information, for example, the budget of the university in a specific year, right? So you can imagine there are a lot of students in Sewanee, but there's only one budget in Sewanee. So if we want to merge two data sets that have different levels of observation, you can use this many to one. There are many people, many observations within one specific observation in the using data set. At the same time, you could also have one to many. So that basically is the reverse, right? So you can have one city and many people. So if the original data set is the city level data set and the M is the people level data set, individual level data set, you have a 1 to M merge. Okay? Okay. So going back, what we're going to do is we're going to merge. In this case, because our original dataset and the dataset we're using to merge into the original dataset are both individual level, so I'm just going to merge 1 to 1, right? There's going to be a 1 to 1 merge. If there's a person in the original dataset, there is a person in the using dataset. Okay? So The next part is going to be I'm going to tell Stata to use what information to merge these people. So remember, there are three variables that we need to use to uniquely identify a person: year, the household serial number, and the person number. So if the person has the same year, same serial household serial number, and same person number, Stata knows that it's the same person, and we're going to be merging using the dataset census age 1990 to 2010.dta. Okay, so basically, I have the original dataset, I have the using dataset to merge, and we're going to be merging by matching people's year, their serial number, and their personal number. And if we click do, you can see that data. It says census age 190 in 2010 is not found, right? So it's because there's a typo. It's very common that people make typos. So if we just change the typo, Stata should be able to merge everything for you. So Stata just says, okay, so everything is merged. We could not find anybody that was not matched. So that means it's a perfect match. The 15,000 people in the original dataset and the 15,000 people in the age using dataset are exactly the same people. So we matched everything. And on top of that, you can see that at the end of the dataset, you can see that the age variable is merged to the right-hand side. If there's a new variable now. And on top of that, there's a new variable called underscore merge. So this underscore merge is very cool. So this variable basically tells you where the merge has come from. Okay, so if we see three here, that means we have found the person in the original dataset and we have found the person in the using dataset. But if we see one, that means we found a person in the original dataset, but we couldn't find a person in the using dataset. And if it says two, that means we couldn't find a person in the original dataset, but we found a person in the using dataset. Again, all of this information is already laid out for you. So if you just go to the merge information, you can see that the master is the original dataset, the using is the dataset that you use to merge. And if it's one, that means they can only find the person in the master. And if it's two, that means that they can only find the person in the use. Okay? So after that, let's remember, because chances are you might be merging more data sets. So this underscore merge variable, we don't want it. So we are actually going to get rid of this variable. And the way to get rid of a variable is called drop. So I'm just going to drop this underscore merge variable. You can see that here, there's a variable here, right? It says underscore merge. I'm just going to drop it. So I'm going to click do. And as you can see, it's only age. The underscore merge variable is gotten rid of. Okay. So now that we have made a lot of changes to the dataset, let's save the dataset again. Remember, we always want to save the dataset in a new name so as to avoid any kind of data contamination. So I'm now going to call the new dataset census 1990 to 2010. I'm going to call it census 1990 to 2010 merged.dta. Replace. So this way, after merging everything, in case I made a mistake, I don't contaminate this dataset. This data set is still usable, right? So I'm going to click do, and the data set is created. And if you go to your folder, you can see that there is a census 1990 to 2010 merged.dta. Okay. Now this is pretty cool. So we have combined a bunch of data sets together, but a lot of times we also want to code certain variables a little bit different. So for example, you can see that there is a variable called sex, right? So this variable is just a sex assigned at birth, okay? So another way that you can actually, maybe you have a lot of variables and maybe you just want to look at one specific variable. All you want to do is actually, I'm not going to type it here. I'm only going to type it in the command because, the do file doesn't, I don't need the do file to show me what we're doing. I just want to look at this specific variable. You can see that this sex variable is coded as 1 and 2. Specifically, 2 means female, 1 means male. Okay, so 2 means women, 1 means men. But you can see that this variable is a dummy variable or a categorical binary variable, right? Binary categorical variable, right? But a lot of times in data with or any kind of data analytics, when it comes to a dummy variable, we don't really use one and two. We use 0 and 1. 0 means no, 1 means yes. That's literally how computer codes are being written as. Okay? So I want to create a new dummy variable that instead of its 0 and 1, I just want to create a dummy variable that is male. So the way to create a variable is, first of all, I'm going to generate the variable male equals to 0. So that means this new variable male is generated for us automatically, and every single observation equals to 0, which, as you can imagine, is wrong, right? Because if we browse sex and male, you can see that somebody who was born as female, we said that male is they're not a male, but somebody who was born as male, we're also saying that person is not a male, right? So meaning, remember, 0 means no, 1 means yes. Okay, so we need to change that. So how are we going to create a dummy variable with 0, 1? Well, we need to replace it. We need to replace certain observations, male to 1, if a if command sex equals to 1. So here is where we need to pay attention to the difference between 1 equal sign and 2 equal signs. 1 equal sign is a condition. So this means that equal, so it's a assignment. I'm assigning male to 0. I'm assigning male to 1. And 2 equal signs is a condition. I'm not assigning sex to be 1. I'm saying that if sex is 1. So imagine this is, and this is equals to. Okay, so first of all, I have generated the variable where male equals to 0. I'm assigning everybody's male variable to equal to 0. And then I'm going to replace those whose sex variable equals to 1. Sex variable is 1 to male equals to 1. Okay, so I'm going to click do. And if I browse sex and male, again, you're going to see that for people whose sex variable is 0, if sex variable is 2, their male is 0, meaning they're not a male. For people whose sex variable is 1, their male variable is 1. So now with this new variable, it's a dummy variable with 0 and 1. Okay, so that is how we generate a dummy variable. Okay. But on top of that, we want to make sure that we label the variable so people understand what we're doing. So I'm going to label variable male, and then I'm going to label it as equals to 1 if the person is male, and 0 otherwise. So this becomes a male dummy variable that equals to 1 if the person is male, and 0 otherwise. Okay, so right now I want you guys to pause the video, and I want you guys to practice again. So instead of generating a male dummy variable that equals to 1 if the person is male and 0 if the person is not male, I want you guys to practice and generate a female dummy variable, and that dummy variable should equal to 1 if the person is female and 0 if the person is not female. Okay, pause the video, and once you're ready, resume the video. I will show you what to do. Okay, all right, welcome back. So, how do we generate a female dummy variable? Very simple. I generate a female equals to 0, right? So this way, if I click do, you can see that now this female variable all equals to 0, which obviously is wrong. So what I'm going to do is I'm going to replace the observations of female equals to 1 if their sex assigned at birth equals to 2, right? Remember, sex equals to 2 means this person is female. And if I do that and click do, you can see that the female is 101110. And you can see that if the male is 0, the female is 1 for this person. Makes sense, right? If this person is not male, if this person is female, according to the binary definition of sex in this data set, right? And if the person is male, this person is not female, so on and so forth. And we're going to label our variable female, and we're going to label it as equals to 1 if the person is female and 0 otherwise. Okay, so this is what we need to do. And after we have made some changes, let's save the data set again. I'm going to call it census 1990 to 2010 merged. In this case, I'm now going to save it in a new name because I know that everything I have done is correct. I just generated two dummy variables. So I'm now going to name it a new name. I'm just going to name it as the original name because I'm not afraid of contaminating the original data set. Okay. And click replace and then click do. Everything is good to go, and my male and female dummy variables are generated. My age variable are merged. Everything is good to go. And before I finish, I save my do file. And in this case, if you look at your folder, you're going to see that you have generated a bunch of new files, including this newest file. And then your do file, everything is correct, right? Actually, there's a typo here, census, right? So I'm going to run this do file again. So census 1990, 2010, right? And then after that, the log file includes everything we have done. Okay, so you can see that the log file has gotten a lot longer because it includes everything that we have done. So one thing I want to make sure that you understand is that when it comes to any assessment and any homework, we are going to be needing your dataset file, your do file, and your log file to make sure that you're doing everything correctly. Okay.